Hello, we're gonna go over the next few questions from the paper, the June 2011 M1. This is question 4 and it's about graphs, velocities and things like that. It says a girl runs a 400-meter race in a time of 84 seconds. Okay, so I'm going to start by writing the information. So the total S is 400 meters and the total time is 84 seconds. In a model of this race, it is assumed that starting from rest, she moves with a constant acceleration for 4 seconds, reaching a speed of 5 meters per second. So for the first section, okay, so I'm going to write here first section, initial velocity is 0, acceleration is unknown, and the final velocity is 5 meters per second in a time of 4 seconds. She maintains this speed for 60 seconds and then moves with constant deceleration for 20 seconds. Okay, so in the second part of the journey, there's a constant speed of there's a constant speed of what she had before, which was 5 meters per second for a time of 60 seconds. And finally there's a third part when she moves with a constant deceleration for 20 seconds. Okay, so in the third part there is an acceleration which is negative and it occurs for a time of 20 seconds, crossing the finishing line with a speed of v meters per second. So we want to, let me write it. So the final velocity for this section is big V meters per second, which we need to find, I guess, and this velocity here is going to be the initial velocity u for this section. Is going to be the velocity here, 5 meters per second, so we also know that. Okay, so looking at these three sections, before we start doing it, let's see what we have. Here we have we know one item, we know a second item, and we know a third thing, so we can find out the missing acceleration. That's good news. Here we only know two things when we normally need three, and here we only know two things also, 1 and 2, when we normally need 3 in order to work things out. So where's the extra information going to come from? Well, from here and from here, which they gave us for the total distance and the total time. Okay, so we need to take these into account when we're using the formulas for these three sections, and that will help us work out what's going on. A graph is probably a good way of solving all of this, and let's see what the rest of the question says anyway. Sketch in the space below a speed time graph for the motion of the girl during the whole race. Okay, so that's 2 marks and that should be quite easy to do. So let's see what the graph would look like. Do you want the speed time graph? Speed versus time. Okay, we don't use an S in mechanics. An S is for displacement. Speed is also got a V. I'm going to make this axis a little bit longer. So let's see what happens. It's the girl starts at 0 speed, then there's an acceleration until they reach a speed of 5, and it doesn't reach any higher speeds than that, so I'm just going to take 5 to be up here so it looks nice and big. 5. Let me label the axes properly, because otherwise I'll get into trouble with possibility of losing marks. Okay, so this should go in a straight line because it's a constant acceleration. It should go in a straight line until it reaches that speed, and this must happen after 4 seconds. Then it goes at a constant speed for 60 seconds. So actually my scale is all wrong. I'm gonna have to do that much more steep. So let's see if I get it from here. Okay, it's not a very straight line. It's difficult with this pen. Imagine that's a straight line. Then it goes flat for 60. Okay, so here we have 4 seconds. Then here we have 60 seconds. And then what happens? There's a deceleration for 20 seconds. So if that's in 4, 20 is gonna be much less steep. So I'm gonna get rid of this guy. It was still not long enough. And I'm gonna add this for 20 seconds, a line like that, where this is going to be 80. No, 60 plus 4 is 64, plus another 20 is 84 seconds, right? So I made a mistake here with the 60. It should have been 64. It already was at 6. It already was at 4, so that should be 64. That's a really easy mistake to make. I'm glad I made it so you can see how easy it is to make it. Okay, it says here 60 seconds after those 4 seconds. So you've got to, when you put it in the Excel, you've got to add all of those seconds to one another. Okay, that's looking better now. So that would be the first 2 marks. Okay, then part B, find the distance run by the girl in the first 64 seconds of the race. Okay, so that was part A. Now for part B, first 64 seconds, so they're asking us for this area plus this area. Right, we need to find those 2 areas. Now, we know that this area plus that area is equal to 400. Right? And that's going to come in handy later. For sure, and I've tempted to use that from now and solve everything in one go, but let's try to do it in steps as they want us to do it. So we wanted the area under these 2 parts. So let's write a formula for that. Here we have 5 times 4 divided by 2, right? For this area. I'm going to call area A, area B, and area C. So part B of the question is asking us for the total distance in A and B. Right? Area A is given by 5 times 4 divided by 2, which is 20 divided by 2, which is equal to 10 meters. And area B is equal to 64 minus 4, which is 60 times 5, and we don't have to divide that by anything, so that's 60 times 5, and that's going to be 300 meters. 5 times 6 is 30, so that's 300 meters. So if this is 300 and that's 10, then this guy here, that area C, is going to have to be 400 minus 310, which is equal to 90 meters. So together all of these have to add up to 400. We knew that from there. So I just added that there because it's probably going to be useful. And now actually if you realize what we just found out is this, the S in this third period, or period C, I should have labeled these the same way, sorry, 3 is C, then S is 300 and is 90 meters. And now look what we have. We have 3 things, these 2 and this thing. We have 3 items, and that means we can find out any other item for that period. I've just realized that the V, this big V, is the final velocity for this section here. So I don't know why I brought it down to 0, right? But it doesn't go down to 0 all the way, because the final velocity is what we're trying to find out. It's a big V, so we don't know if that's 0 or not. So I shouldn't have drawn that line down there all the way. It should have gone up to some value. Hopefully you saw that while I was doing it and you were like, what is he doing? So that's supposed to go until a certain velocity V, which we don't know, and this is what we're really looking for. This big V there is what we're looking for. And so the area that we just worked out right now to be to be 90 meters is this one here, all of this. Okay, that's 90 meters. Okay, so this is still valid though. All of this helps. S, U, and T can help us to get V now, because we know the initial velocity, we know the distance traveled, and we know the time that it takes for it to decelerate, and so we can find the final velocity. Anyway, so we've done B, or the area of in the first 64 seconds is 310 meters would be the answer. So right, the distance traveled in A and B would be these two together. So that's distance distance 64 seconds equals 310 meters. Okay, the next part of the question was find the value of V. 5 marks. Don't know why they give us so many marks, but it's going to be a nice and generous way of getting them. We have all of this information here. So to find big V, we just need to use an equation with U, S, T, and V. V, we already have 3 things here, so we must be able to find the V with no problem. Let's use this guy first. S is equal to UT plus half AT squared. We can use this, since we have time, we have S and we have U, we can use this to find A, and then once we have A we can use one of the others to find the V. The exam question wants us to find the A in the next part anyway, so we already are doing the 7 marks in one go. Okay, and we are able to do that in a way. Some of the marks that are awarded for this part we already worked out by finding out what this displacement was, 90, by looking at the other stuff before, so some of that is included there. Okay, so let's find what A is from this formula. Okay, S minus UT divided by half T squared will be equal to A. So A is then going to be negative, hopefully, and let's see what comes out from there. S is 90 minus 5 times T, which is 100. 5 times 20 is 100. So that's already negative, divided by half T squared, which is going to be positive. So that's going to be a negative acceleration, which is good news. 1/2 times the time, which is 20 squared. So the acceleration is 90 minus 100, which is minus 10, divided by, it's going to be a very small number, divided by 20 squared times 0.5 is minus 0.05. So the acceleration is minus 0.05 meters per second squared. Very small acceleration. Okay, he does it for quite a few seconds. He doesn't travel that much. So let's see. If that is the acceleration, let's now find the V. Okay, and V, we can use V squared equals U squared plus 2AS, right? V squared equals U squared plus 2AS, and that is equal to 5 squared plus 2 times minus 0.05 times the displacement, which is 90 meters, and then we square root all of that to find v. So s squared u squared is equal to 5 squared minus 2 times 0.05, that's the minus there, 2 times 0.05 times 90 is equal to 16. So 16 is v squared, therefore big V has to be 4 meters per second, so it goes down to 4. This is now 4. Now we have 4 and the acceleration 0.05 meters per second squared. And here in the mark scheme they have 310 for the first answer, which we got correct, 4 for v, and 0.05 meters per second squared for the acceleration. So that was all, it didn't take too long, and that was for how many marks? That was for 5, 10, 12 marks. So that was a pretty friendly question. Hopefully you found that okay. So I'll do the next question, question 5, on the next video, and I'll see you then. Take care.